Hi, welcome to my video on find or use the general form of an ellipse. Find the foci and eccentricity of this ellipse. So we have to take this equation, which is in the general form, and change it to a standard form. So that means we'll group the x's and we'll group the y's. And remove the constant 164 to the right and make it positive. So we'll factor out the 9 to make the coefficient in front of the x squared 1. So we factor. So 9 into 9x squared is 1. 36 divided by 9 is 4x. And we'll take out the 25 to make the coefficient of y squared is 1. So 25 divided by 25 is 1y. 50 y squared. Negative 50 divided by 25 is negative 2. So we made the coefficients of x squared and y squared 1. Now we'll complete the square. So we'll go x squared and we'll take a half of 4 and make it a 2. 2 squared is 4. And we'll take a half of negative 2 and square it. Negative 1 squared is 1. So we have 164. Because I put a 4 here to complete the square, 4 times 9 makes 36. I put a 1 here to make this a perfect square trinomial and complete the square. 25 times 1 is 25, so we balance it. So that gives us 9. And this is a perfect square trinomial, so the square root of x squared is x. Half of plus 4 is a plus 2. And this is a perfect square trinomial, so the square root of y squared is y, and half of negative 2 is negative 1. And that gives us 200 plus 25 is 225. So now I'll divide by 225 on each side. So divide here by 225, I get a 1. And here, 25 goes into 225 9 times, so I get a y minus 1 squared over 9. And 9 into 225 goes 25, so I get an x plus 2 squared over 25. Now we have an ellipse in standard form. So on the ellipse, so what I'm going to do is let's pick up the center. C, the center is negative 2, opposite of x plus 2. Opposite of a negative 1 is a plus 1. So that's the center. And a squared is 25. So that means a is the square root of 25, which is plus or minus 5. B squared is 9. So the square root of b squared is plus minus, b squared is 9, so the plus minus square root of 9 is 3. Now, let's draw a little picture of what we have here. And I always like to draw the picture of the ellipse. So we have a center of negative 2, 1. X is negative 2. And y is negative 2, 1, which is right there. And the stretch is plus or minus 5. So this is the vertices. So if I go 5 right, so it's 1, 2, 3, 4, 5. So this is vertex 1 right here, which is 3, 1. And if I go 5 left, 1, 2, 3, 4, 5, I get vertex 2. So that becomes negative 2, so it makes it negative 7 and a 1. And we want the foci, so the foci are, now they get the foci are on the major axes. I could get the co-vertices. I'll just get the co-vertices anyway. So the co-vertices are plus or minus 3. So from here I go 3 up. So 1, 2, 3. 1 is there. So that's a co-vertex. and that one is 3 up. That's a negative 2, 4. And I go 3 down. 1, 2, 3 right there. So that's negative 2, negative 2. So that's the second covertex. And the ellipse looks like this. And again, it's just approximation, not drawn to exact specs. So we need to get the foci, and the foci are on the major axes. So c squared is equal to a squared minus b squared. So c squared, a squared is 25. B squared is 9, because that's a squared and b squared. So c squared is 16, so c is plus or minus 4. So if you add 4, so if we take the center and add on 4, 1, 2, 3, 4, so you get right there, and that's foci 1. So that's going to be a 2, 1. So one of the foci is 2, 1, and foci 2 is, you go 4 this way, 1, 2, 3, 4. So this one is foci 2, let's call it F2. So that one is a negative 6 and 1. So negative 6, 1. So these are the two foci that we wanted. And the eccentricity E is equal to C over, because it's horizontal, is C over the A. If it was a vertical major axis, it'd be C over B. So C is got to be positive as 4, and the A is 5, because these two numbers got to be positive, so it's 4/5. So that's the foci and the eccentricity when you change this equation to standard form. And I mapped it so you can see that the vertices and the foci lie on the major axis, which is the horizontal. So that's why we add, if you go this way, we add the C and the A to the center on the X, and when you go this way, you add it to the Y to get the covertices. Okay, that's number 1 done. Now, different one, find the equation of the ellipse in general form if the vertices are 2, 13, 2, negative 7. Foci is 2, 9, and 2, negative 3. Again, let's draw a picture, a rough picture of what we have. We want to do exact. So the vertices are x's 2 and 13. So I'm just going to just take 2, 13 to be right there, and 2, negative 7. So that's just, again, these are not exact, so we're up here and down here. And the foci are 2, 9. So 2 going to 9 is, let's say, right here. Remember, that's 2, 13, so 9 is, as you can see just before it, and 2, negative 3. So let's take 2, negative 3 to be here. Again, they're not exact. So this is the vertex 1, and this is vertex 2, and this is foci 1, and we can call this one foci 2. So, as a result, because we have the vertices, the difference is on the vertical. So this is 13 to a negative 7, so that's 20. So that means this is B on the Y, so 2B is 20, so that means B is 10. And we have the foci on this major axis on the ellipse, so we have a 9 to negative 3, that's a 12, so 2C is 12, so C is 6. So we got B and C. Now we need to get the A. So we know that C squared is equal to, now normally it's A squared minus B squared if it's horizontal, but in this case the vertical is the major axis, so it's B squared minus A squared. So 6 squared is 10 squared minus A squared. So that means move the A squared to the left, and we just do that, and that gives us 100 minus 36, so a squared is 64, so a is plus or minus 8. So what we have is we have to get the center. So the midpoint between the foci is the center, and the midpoint between the vertices is the center, so it should be the same one. So if we take the foci or the vertices, it makes no difference. If you take the foci 1, which is 2, 9, and you take foci 2, which is 2, negative 3, and we get the middle, so we take the 2 and add on 2, divide by 2, and take the 9 and add on negative 3, and divide by 2. That gives us 4 over 2, which is 2, and that gives us 6 over 2, which is 3. So this is the center. So we have the center. So we have this is an x minus h all squared over a squared. Y minus k all squared over b squared is 1. So since the center is 2, 3, so this is x minus 2, and it's y minus 3. So we change the signs, negative, negative, and a squared is, a is 8, but a squared is right here is 64, and b squared is, b is 10, so that means that if b is 10, b squared is 100, so we have 100 right here, and we want the equation in general form. This is the standard form. This is a squared, b squared, perfect. So now the LC, I want the general form, so we have to find the LCD, which is 6400. So we multiply each part of the equation by 6400, 6,400. So that goes into that 100 times, so we get 100 x minus 2 all squared, and 100 into 6,400 is 64, so we get 64 times y minus 3 squared. 1 times 6400. So we'll do PEMDAS. We have to square first, so we take the binomial and square it, so it's x squared. And the product is negative 2 doubled, negative 4. Negative 2 squared is 4, plus 64. And we're going to square this. We're going to square this binomial, so it's y squared. Product is negative 3 doubled. Negative 3 squared is 9. And now we have the squaring done, so we multiply by 100. So we get 100 x squared minus 400x plus 400. 64 multiplied by this trinomial is 64y squared. 6 times 64 is a negative 384y. 64 times 9 is 576. And now let's put the equation in the right order. So we group the x's. Oh, no, we put the x squared and then the y squared. We only group the x's if we're completing the squares. The general form is x squared, y squared, x, y equals the constant. So it's a 400 plus 576 minus 6400. So the final equation in general form is 100x squared, 64y squared minus 400x minus 384y. And when you add all that up, you get a negative 5424. Use your calculator or your head. And what I did, I used my calculator. And there's the general form that represents the ellipse, which has these vertices and these foci. Okay, that brings us to the end of this video. And again, if you like my video, click on the like button and click on the subscribe button. If you're not a subscriber, visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content. That's the content that's on my YouTube channel called Math Fully Explained. Notice just one word. Thank you for viewing my video. Hope the video helped you. Bye-bye.